Car suspension plays a crucial part in safety and comfort on the road. Our project seeks to help in its study, designing and manufacturing a test rig to help research different suspension configurations and how they affect the response of the system. A quarter car module is commonly used to evaluate the performance of the suspension and is composed of the sprung mass, a spring and damper representing the suspension components, unsprung mass, and a spring simulating tire stiffness. For our project, we decided to make the test rig horizontal, allowing for higher values in the sprung and unsprung masses. This test rig would have the same natural frequencies and modes of vibration, with the equilibrium position of the masses being the only difference. Using MATLAB and Simulink modules, we decided to reproduce the input at the axle rather than the road profile, eliminating the spring. Leaf springs holding the masses were also introduced to control the horizontal displacement of the system. The final test rig was designed with functionality and ease of manufacturing in mind. The frame supports the masses and offers protection from moving parts. Using Abacus, the response for several modes of vibration was analyzed to ensure its structural integrity during testing. It was manufactured out of a steel tubing with a 25mm square profile, cut to size and welded together. The mass holders represent the sprung and unsprung masses of the system. The parts were water jet cut out of a steel plate and then welded. Steel plates were added to the masses to adjust the weight and then held in position when testing with clamps. The leaf springs supporting the masses were cut out of a thin steel plate with 3 different interchangeable stiffnesses. The bespoke component mounts allow for the versatility of our test rig. They were designed specifically for each part and 3D printed in PLA. Different dampers and springs were fitted between the masses to represent the suspension. Accelerometers connected to an Arduino were used to collect data on the movement of the masses. The electromechanical shaker, controlled by the amplifier and signal generator, provided a force input simulating the axle movement. And lastly, the safety screens, made of perspex, were mounted around the frame to provide protection from the moving parts.